Sketch graphs of f of x equals 1/2 to the x and g of x equals log base 1/2 of x on the same xy plane. Then find the domain and range of each function. For f of x equals 1/2 to the x, I want to use a table of values to sketch the graph. And the values I'm going to pick are going to be -3, -2, -1, 0, 1, 2, and 3. And I'll start from the bottom up. 1/2 cubed is 1/8. 1/2 squared is 1/4. 1/2 to the first is 1/2. And 1/2 to the 0 is 1. Now when we raise 1/2 to a negative power, that negative power causes us to take the reciprocal. And so when we do that, we end up with a whole number. 1/2 to the negative first is 2. 1/2 to the negative second is 4. And 1/2 to the negative third is 8. So we end up with the points -3, 8, -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4, and 3, 1/8. Because the base of this exponential function is less than 1, instead of increasing to the right and asymptotically approaching the x-axis to the left, here we're actually going to be going up as we move to the left and then asymptotically approaching the x-axis on the right-hand side. So this is the graph of f of x equals 1/2 raised to the x power. Now, because g of x equals log base 1/2 of x, it is the inverse function of f of x, and we know that when we have inverse functions, their graphs are reflections of each other across the line y equals x. So we can take advantage of this when we sketch the graph of our logarithmic function. And for every point we have on our original graph, we can take the point where the coordinates are swapped for the other graph. So here, instead of 0, 1, we're going to have 1, 0. Instead of -1, 2, we're going to have 2, -1 down here. Instead of -2, 4, we're going to have 4, -2. Instead of -3, 8, we're going to have 8, -3. And then if we look to these values to the right of the y-axis, we've got 1, 1/2, which becomes 1/2, 1. We've got 2, 1/4, which becomes 1/4, 2. And we've got 3, 1/8, which becomes 1/8, 3. And as we connect these dots in a smooth curve, we can see that we're asymptotically approaching the x-axis from above, and then as we move to the right, we're going further and further below the x-axis. So this is our graph of g of x equals log base 1/2 of x. You could also do this with a table of values if you want. It would be good to pick values of x that are powers of 1/2. So we could do 1/8, 1/4, 1/2, 1, 2, 4, and 8. And you would end up getting the same output values as the input values for the inverse function. -3, -2, -1, 0, 1, 2, and 3. You would end up getting the same graph either way, but I want us to get a little bit of practice looking at graphs of inverse functions and using these reflection properties so that we can get more comfortable with them. Now, one more thing, we were asked to look at the domain and range of each function. For the exponential function, the domain is all real numbers, and the range is the set of numbers from 0 to infinity, the positive numbers. This is the same as the other exponential functions we've seen, so it doesn't matter if the base is larger than 1 or smaller than 1, it'll still have this domain and range. And we know that for the inverse function, the domain and range will swap. So here the domain will be positive numbers, and the range will be all real numbers. And we can see that represented by our graph. The graph does not move to the left of the y-axis, so we know that our domain does not include negative numbers. And as far as the range goes, we do go both up and down. It just looks a little bit different than when we had a base that was larger than 1. Instead of going down asymptotically, we're going up asymptotically. And then instead of going up as we move to the right, we go down as we move to the right. So the graph does look a little bit different, but it does still have the same domain and range as the other logarithmic functions.